Hey everyone, today we're going to be solving linear systems graphically. So a linear system is a set of two or more linear equations that are considered at the same time, and the point of intersection is the point where the two lines intersect. So when we are trying to solve a linear system, our goal is to find the values of the variables in the system that satisfy all of the equations. So what is that saying? So what we're going to be doing is we're going to have two linear equations that we consider. So let's say this is line 1 and this is line 2. Sorry, they're very bad drawings, but they're going to cross at some point, right? So they cross right here. This is our point of intersection, and it's a point, so it's going to have an x and y value, right? And this entire unit is us solving for this point of intersection, okay? So all we're going to be doing is we're going to be solving for the x and y values that are basically satisfying line 1 and line 2, because if you see, this xy point is on line 2 and it's on line 1. So I've given you an example here. The point 73 is the solution to x plus y equals 10, so the first line, and this line over here, 4x minus 2y equals 22. So here, our point of intersection is 73, and I want to prove to you that this point is the actual point of intersection. And the way we want to do that is we want to show that this point right here satisfies line 1 and line 2. So let's call this line 1 and this one line 2. So line 1 is x plus y equals 10, and line 2 is 4x minus 2y equals 22. So another thing you see here is this is our x and this is our y. So x is 7 and y is 3, right, from the point right here. And so how are we going to prove that the point satisfies the lines? We're going to do the left-hand side equals right-hand side test, or check. So left side here is this portion of everything on this side of the equal sign, which is x plus y. So left side is x plus y, and the right side is 10. Move this. So what we're going to do is we're going to sub in our x and y values into here. We're going to compute and we're going to see if the left side equals the right side. So x is 7, y is 3. The right side stays the same because it's just 10. So 7 plus 3 is 10. And the right side is 10. So do they equal? Yes, they do. So therefore, left side equals right side. So I have just proven to you that this point satisfies this line because left side equals right side. So now we're going to do the same thing for this line right here. So here, left side is 4x minus 2y, and the right side is 22. So again, we're going to sub in the point here, so x7, y3, and we're going to compute and we're going to see if that equals the right side, which is 22. So 4 times 7 minus 2 times 3. The right side is still 22. So here we have 28 minus 6. So 28 minus 6 is 22, and the right side is 22. Are they equal? Yes, they are. So therefore, left side equals right side. So because left side equals right side for both of the equations, we can say that therefore this point is indeed the point of intersection. So linear systems can be solved using 3 different methods. We have graphing, which is what I'm going to cover in this lesson. We have substitution and we have elimination. So these ones are more algebraic, and I'm going to have a video lesson on each one, so stay tuned for those. So when we're solving by graphing, you can graph the lines using different techniques. So the slope y-intercept form, the x and y-intercepts, or by creating a table of values. Now in my previous video, went over all of these techniques in a lot of detail, so I highly suggest you go and watch that before you watch this video, because I'm not going to be explaining the techniques. We're just going to be solving and graphing. So now this is a little bit of the conceptual or theory behind this unit. So It's not hard, it's very straightforward. I'm going to do my best to try and explain it to you. So linear systems can have no solutions, one solutions, or infinite solutions. So there are three cases that we can have when we're solving for the point of intersection. So we're going to look at each case on its own. So the first one is when we have one solution, so we're just going to have a point of intersection, right? So basically the slopes will be different and the intercepts will usually also be different unless if the line intersects on an axis. So now to give you an example, let's say this is my Cartesian grid, and I'm going to just come up with some lines, so they're not obviously going to be exact, but let's say this is line 1, and this is y is equal to 2x plus 1, and then my second line is going to be this. So let's say this is y is equal to, I don't know, negative 2x. So as you can see, I have two lines right here, right? And let's say if you weren't given the graph, how would you know what situation you have, right? How would you know? You would have to graph them to know, but there is a way we can tell what to expect based off the situation. So if you look at the equations, we see that the slope here is 2 and the slope here is negative 2. So our slopes are different. And if we look, that our intercept here is positive 1, our intercept here is 0. So should we expect to have a point of intersection? Yes. And as you can see, the lines, they go different directions, but eventually they will have to cross, right? So our point of intersection here is right here. This is the point of intersection. This is x and y, so indeed we will get a point of intersection. The second situation is when we have no solution, so we will not have a point of intersection. So when does this happen? This happens when the slopes are the same and our intercepts are different. So for example now, let's take a look at another two sets of lines. So let's say if I give you y is equal to, say I do this. So let's say this one is y is equal to 3x plus 2. And then this line right here is also, it has to have the same slope, right? So y is equal to 3x minus 2. Let me make this. So y is equal to 3x minus 2. So here we have y is equal to 3x plus 2 and y is equal to 3x minus 2. So as you can see, the slopes are the same because this is 3 and this is 3, but our intercepts are different. This one has a positive 2 intercept and this one is negative 2. So what do we get? We get lines that are parallel and distinct. So parallel lines, they're just going to keep going their separate paths, right? They're just going to go like this. It's not like this line is going to turn and somehow meet this line. No, they're going to go their separate ways. So you're not going to have a point of intersection in this situation. So now the third case is when you have infinite solutions. So when does this happen? This happens typically when the slopes are the same and your intercepts are also going to be the same. So for example, I can give you the line, let's say, I don't know, y is equal to x plus 1. And then I can also give you a second line, which I will also call y is equal to x plus 1. So as you can see, these lines are the same line because they have the same slope, which is 1, and they have the same y-intercept, which is also 1, right? So they're the same line. So what do we call this? We say that these lines are parallel and coincident. A fancy way of saying they're the same, basically. And so we get an infinite number of point of intersections because these lines are essentially laying on top of each other, right? So you're going to have an infinite number of intersections. So these are the three cases that you're going to deal with. It's very important to recognize what case you have and what case you're dealing with. It's just going to help you in general to conceptualize and solve problems. So now let's move on to some examples. So here I have some steps for solving a linear system graphically. So the first thing you want to do is you want to rearrange your equations to the slope y-intercept form. Why? Because it's the easiest way to graph the lines and compare the slopes and y-intercepts so you can tell what case you're dealing with, right? Because here I've given you different criterias of where the slope will be the same, where the y-intercepts will be the same or different. So you want to be able to compare your lines in that sense. Then you're going to graph the equations and you're going to find out whether there is a point of intersection or not. Then you can also verify your point of intersection and see if it satisfies the equation of both lines. How are you going to do this? You're going to do the left side, right side check, which is what we did here, right? So you can double check your answer. So usually during tests, if you find your point of intersection and you double check, you will know whether you have the right answer or not, or if you've made a mistake. And then obviously you communicate your solution. So here, example 1, I have a system right here. So I have y is equal to 2x plus 1, and I have x plus 2y equals negative 8. So let's say this is equation number 1. So equation number 1 is y is equal to 2x plus 1. Is this in the slope y-intercept form? Yes, it is. It's in the form of y is equal to mx plus b, where m is 2 and b is 1. So I will just leave that there. And then our second equation is x plus 2y equals negative 8. Is this in the form of y is equal to mx plus b? No, it's not, right? We're going to have to rearrange because as you can see, y is not isolated. It's not on its own. So what we're going to do is we're going to rearrange it. So we want to move x over to the side. So we get y is equal to 2y is equal to negative x minus 8. And then you want to divide everything by 2 to get rid of, to isolate for y, right? Divide everything by 2. So then you get y is equal to negative 1/2 x minus 8 divided by 2, which is just 4. So now we have an equation in the form of the slope y-intercept form. So now, here our m is, so our slope is 2 and our y-intercept is positive 1. Here, our slope is negative 1/2 and our y-intercept is negative 4. So are the slopes the same? No, they're not. They're different. Are the y-intercepts the same? No, they're also different. So if we look at our situation, our slopes are different, the y-intercepts are also different. So what are we expecting? We are expecting to get a solution. So now we're going to graph these lines. So I'm going to color code line 1 is going to be blue and line 2 is going to be pink. So in order to graph this line right here, y is equal to 2x plus 1, we need our slope. So our slope is positive 2. If you remember, we're going to graph using rise over run. So this is going to be positive 2 over positive 1, right? So our rise is going to be going up 2 units and going right by 1 unit. And then we're going to do the exact opposite to get the other side of the line. So it's going to be negative 2 over negative 1. So we go 2 units down, 1 unit left. If you're very confused about what I'm doing here, I highly suggest please watch my previous video because I explained all of this. So I don't want you to be confused. I want you to know why we're doing this and what's going on. So we're going to go ahead and graph the y-intercept, which is positive 1. So that's right here. And then our slope tells us to go up by 2 units and to the right by 1. So up 2 units, right by 1. So the next point is here, up 2 units, right by 1. And we're just going to continue this pattern to get as many points as we can. And now we're going to do this side, but we're going to do the exact opposite. So if we went 2 units up here, we're going to go 2 units down here. We went 1 unit right, so we're going to go 1 unit left. So 2 units down, 1 unit left, we're here. So just continue the pattern and then connect all of your points. And this is line 1. So see how fast you have to be when you're graphing these lines, right? Like during a test, you can't spend like 10 minutes graphing a line, right? That's a skill that you need to be very fast and accurate with. So make sure you practice graphing. So here, for this line, our slope is negative 1/2. So if we do rise over run, let's take the first case where rise is negative 1 and run is 2. So we're going to go down 1 unit and we're going to go 2 units to the right. And then our second situation is when the negative sign is in the denominator, so 1 over -2, so we're going to go 1 unit up and 2 units to the right. So again, we're just doing the opposite of what we did here. And our y-intercept is -4, so let's plot that point. Y is equal to -4, that's right here. And then our slope tells us to go down 1 unit and then to the right by 1, so that's going to be like this. So we're going to go down 1 unit and then we're going to go to the right by 2, so this way. So down 1, right 2, like this. And now we're going to do the exact opposite of what we did here. So instead of going down 1 unit, we're going to go up by 1 unit. And since we went 2 units to the right, we're going to go 2 units to the left. Okay, so now that we have our points, we're going to connect all of them. And so now let's label our lines as well. So this one is 2x plus. Okay, so now if we look, do these lines intersect? Yes, they do. They intersect at this point, right? This point is shared. Sorry, my lines are really bad. They're not straight at all, but you can see that this point intersects between both of them. So right here. So therefore, we do have a point of intersection, and the point of intersection is -2 and -3. So now that we've found the point of intersection, we can also double check by doing the left side equals right side test. So let's do that. So our first equation was y is equal to 2x plus 1. And then our second equation was x plus 2y equals -8. So now what we're going to do is we're going to sub in this point into each equation. So x is -2 and y as -3, and we're going to see if left side equals right side. So here left side is y and right side is 2x plus 1. So what is y? Y is -3, right, from the point. And what is x? X is -2. So 2 times -2 plus 1. So this is going to be -4 plus 1. So -4 plus 1 is -3. So do they equal each other? Yes, they do. So therefore left side equals right side. So the point satisfies this line. Does it satisfy this one? We're going to check. So left side here is x plus 2y, and the right side is -8. So now we're going to sub in. So x is -2, and y is -3. So we get -2 minus 6. Is -2 minus 6 -8? Yes, it is. Do the sides equal each other? Yes, they do. So therefore left side equals right side. And therefore it satisfies this equation. So therefore this is the correct answer. So this is a way you can double check. So that's how you would do that. You would first rearrange your lines to the slope y-intercept form. You would find your slope and your y-intercept. From there you would find your rise over run, and then you would just simply graph your lines. And once you find your point of intersection, you can do the left side equals right side test for each equation. Again, if you're confused about the slope technique, please watch my previous video. I will link it in the description. All we're doing is we're taking the slope, and I divide it by 1 here because, again, 2 divided by 1 is still 2, and that way I can represent it as a fraction to get my rise and my run, and then just do the exact opposite there. So here we're going to be solving this linear system. So I was nice. I already gave it to you in the slope y-intercept form. So line 1 is y is equal to 2x plus 3. And line 2 is y is equal to 2x minus 4. So we already have them in the y is equal to mx plus b form, so we don't have to do any rearranging, but let's take a look at what our slope is. So our slope here is 2. Our y-intercept is positive 3, which you can also write as 0, 3. Here, our slope is 2. Our y-intercept is negative 4. Also 0, negative 4. So now let's take a look. So we know our slopes are the same and our y-intercept is different. So should we expect to get a point of intersection? No, because if we take a look here, our slopes are the same and our intercepts are different. So what we should see are parallel and distinct lines. So if I was on a test, I would just say there is no point of solution because the lines are parallel and distinct. So I wouldn't even spend time graphing because I could tell just by looking at the lines that we're not going to have a solution. But if your teacher wants you to graph and you want to graph and see for yourself, then I will also do that to show you and prove to you. But so here our slope is 2. So we want to write this as rise over run. So we would say it as 2 over 1. So our rise is going up by 2 units and going to the right by 1 unit. And then if I want to do the opposite, I do negative 2 divided by negative 1 because that's still positive 2. And so you go 2 units down and you go 1 unit left. So now we can graph this first line, which I will make purple. So our y-intercept is 3. We're going to go up 2 units and to the right by 1 unit. And then you're going to do the exact opposite here. So you're going to go down 2 units and then to the left by 1. And then you can connect the points. So this is our first line. This is y is equal to 2x plus 3. Now, if we take a look at our second line, which I'm going to do here, so our slope is 2, so we can say rise over run is 2 over 1, which is up 2 to the right by 1. It's the same thing here. It's the same thing here because the slope is 2, so it's the same. But I'm still going to write it for you. This is negative 2 over negative 1, so we're going to go down by 2 units to the left by 1. But our y-intercept here is negative 4. So here, negative 4, and then we're going to go up 2 units and then to the right by 1 each time. So if I do that, it's like this. And then do the exact opposite, so go down by 2 and go to the left by 1. Okay. So now if I were to connect all of these points, oh, that's terrible. Okay. Still not the best, but I don't have a ruler, so this is the best I can do. So now, if you take a look at these lines, y is equal to 2x plus 3 is like this, so it's just going to keep going on and on. This is y is equal to 2x minus 4, which also goes on and on. Are these lines ever going to intersect? No, they're not, because they're parallel and they're distinct. So now we can say therefore, so therefore no point of solution, or sorry, no point of intersection, because the lines are parallel and distinct. So now the last situation is this system right here. So I have given you x plus y equals 3 and 2x plus 2y equals 6. So let's rewrite this. So x plus y equals 3 and 2x plus 2y equals 6. So we have these two linear equations right here, and we can go about rearranging them and then, comparing the slopes and y-intercepts. But if you just pause and look at them for a second, they're very similar because essentially they're the same, because if you take line 1 and let's say we multiply this by 2 on both sides, won't we get 2x plus 2y equals 6 if I multiply everything by 2? And is that not the same thing as this line right here? It is, right? I can also take line 2, and let's say I divide everything by 2. I'll get x plus y equals 6, right? Or no, sorry, I forgot to divide the 6 by 2. 6 divided by 2 is 3, so you will get x plus y equals 3, which is the same thing as this, right? So we already know that these two lines are the same, hence we're going to get an infinite number of solutions. So this is why I kind of want you guys to be very observant when you're solving problems and really looking at what you have, because that way it just helps you to figure out, what you're working with. And now you know that, okay, this is going to have an infinite number of solutions. So do you even need to graph it? Honestly, no, because you can tell just by looking. But I'm going to go through the whole entire process for you. So line 1 was x plus y equals 3. We want to write this in the y is equal to mx plus b form, which is this form right here. So we're going to rearrange. We're going to move x over to the other side. So we're going to get y is equal to negative x plus 3. Now let's take a look at line 2. Line 2 is 2x plus 2y equals 6. Let's rearrange it to the slope y-intercept form. So move all of this to the other side. So we get 2y equals negative 2x plus 6. Now you want to divide everything by 2 to isolate for y, right? To get it on its own. So you will get y is equal to negative 2 divided by 2 is negative 1, and 6 divided by 2 is 3. So as you can see, y is equal to negative x plus 3, y is equal to negative x plus 3. Wow, there's this exact same line. So now we can graph them. So we know that our slope is negative 1, and we know that our y-intercept is 3. So our slope is negative 1, so we want to represent this as rise over run. How can we do that? We want to represent negative 1 as a fraction, so do negative 1 divided by 1. Because negative 1 divided by 1 is still 1, I haven't changed the slope, right? The slope is still negative 1. But this way, I know that my rise is go down by 1 unit, and then my run is go to the right by 1 unit. And now if I want to do the opposite, I will say rise over run is equal to 1 divided by negative 1. So I just made the denominator negative instead of the numerator, because this is still negative 1, so I haven't changed the slope. So this way, what we will get is our rise is going up by 1 unit, and our run is going to the left by 1. And it will always be the exact opposite of this one. So now let's graph this line. So our y-intercept is positive 3, which is right here. Our slope tells us to go down 1 unit and then to the right by 1 unit, which is right here. So like this. And then to do the opposite, we go up by 1 unit and then to the left by 1. So up by 1 to the left by 1. So this is our line, and then you can connect all of your points like so. So this is the line y is equal to, it's always best to label your lines as the original ones as given in the question. But honestly, it doesn't matter, but it's just best to label what's given in the question. So this is y is equal to x plus 3. Now in a different color, because the lines are, the same, I'm going to do the second one in, I'll do the second one in pink. And it's going to be the same, so literally the same points and everything. And then I'm just going to go over it. It's the same line, so then we can label this one 2x plus 2y equals 6. So therefore from this we can say that therefore we have an infinite number of solutions because the lines are the same. You could also say they are parallel and coincident. Parallel and coincident. So these are all the different situations. I've shown you each case when you have one point of intersection, when you have none, when you have an infinite number. So, it's really just about practicing and getting used to seeing it. I have the notes right here for you. Again, as you can see, graphing is very important. I graphed these lines in literally under a minute. So, you have to get good at graphing and you have to be fast and accurate. Again, if you are uncomfortable with graphing still, I will post the link to the video, that my previous video lesson where I went over graphing, because you have to know how to graph in order to do well in this unit. So that's all for now, and I will see you in my next lesson.